This is part 2 of our section on 4.9. We're going to look at reflections and coordinate notation for a reflection. So this would be our pre-image, and this is going to be our image. How do we get this onto there? Well, we're going to flip it over the x-axis. The notation would look like this. You're going to take all of these ordered pairs, x, y, and you're going to keep the x the same. So this x value is the same as this x value. This x value is the same as that x value, so on and so forth. The thing that's different is the y value. The y value is now the opposite. So if this was, let's just say we went 2 to the right and 3 up, you're still going to go 2 to the right to get to this point, but now you're going to go 3 down. You're just taking the opposite of the y values. That's how you flip over the x-axis. Now, if you want to do the same thing over here and flip over the y-axis, what you're going to do is you're going to keep the y's the same, but you're going to flip the x's. So if it was positive, you would make it negative, and if it was negative, you would make it positive. So you're taking the opposite of the x. How does that look? Well, here's an example. We have this figure. We want a mirror image of it down here, and that would be pretty easy to do just, I think, by appearance. I think you could probably figure it out, but here's how you do it using that notation. We want to flip over the x-axis. So what that means is you need to keep your x values the same. So we have these 5 points. All of them have an x value. Keep all of those x values the same. That's how you reflect over the x-axis. Then take your y values and you change them. If it's a 0, you're not really taking the opposite of a 0, but you can take the opposite of a positive 2 and make it a negative 2. You can take the opposite of a positive 4, make it negative 4. There's your 5 points that would give you the image of this figure. So negative 1, 0, that lives right here. Negative 1, 2, negative 1, negative 2 lives here. Positive 1, negative 2 is here. Positive 1, negative 4, and then 7, 0. Now again, I think you could have done this freehand without finding those coordinates. But this is a nice, easy, simple one to start with, just so you can see that you're keeping the x's, but changing the y's, taking the opposite of the y values. That's how you reflect over the x-axis. Now, if we were to reflect over the y-axis, then you would keep these and switch those. Rotations are a little bit different, and they're a little bit more difficult. You need a little bit more knowledge of geometry to actually pull this off. So we're not going to do a lot of rotations, but I want you to understand how you would do a rotation. We want to take this pre-image and put it onto this image by rotating. How would you know that this is a rotation of that? Well, here's what you would do. You have this point right here, and you want to see if it's a rotation of that point. So you're going to take a straight edge and connect this point to the origin, and then the origin to this point, and you're going to measure this angle. It says it's 90 degrees right here. Now, I need to do that for every single vertex that this shape has. So if I want to look at that point there, it's going to map to this point. How would I determine if this point rotates to that point? Well, take a straight edge and go from that point to that origin, and then this origin to that point. And again, you measure this angle. And it's hard to see because I didn't do such a great job, but with this mouse, it's kind of difficult. But the idea is, if this is a 90-degree angle as well, then it's a rotation. But you got to do this for every single vertex. So it gets kind of complicated. Same thing over here. It doesn't matter if you're rotating clockwise or counterclockwise. If we're going from this point to this point, measure this angle. Let's say we're going from this point to this point. Again, go to the origin with a straight edge, and then go from the origin to that other point, and then measure this angle. Is this a 60-degree angle? Well, if it is, then this could be a clockwise rotation, but you got to check it for every single ordered pair. Okay, so that's how rotations work. And you might see a couple examples like this on your assignment. They give you this segment AB and this segment CD, and you want to know if segment CD is a rotation of segment AB about the origin. So what you would do is you need to measure this angle AOC. Whatever that angle is it the same as this angle BOD? If the green angle and the yellow angle are the same, then these segments are rotations of each other. So that's why they ask you for the measures of those angles. We're not going to talk about how to actually calculate that angle measure yet. We'll try to save that for when you're here. But that's how you would do it. Same thing down here. So we're going to go from B to O and O to D, measure that angle. Go from A to O and A to C, measure that angle. Now I think you can tell, see how this green angle is completely inside of the yellow angle, and the yellow angle is definitely a little bit bigger. Can these be rotations of each other if one of these angles is bigger than the other? Definitely not. This one looks reasonable. We would actually have to use some geometry to figure that out though. And again, we're not going to focus on that so much. I just want you to know what a rotation would be or what it would look like.